Hello, in this video I'm going to show you how to do various things in Stata that relate to simple linear regression. So let's start with a scatter plot. So we're going to do a scatter plot and line of best fit for wage and education. And notice that I'm using a data set from Wooldridge, which is a lot smaller than the American Community Survey data that you'll be using in the data set. So the command for graph is graph, telling Stata that's what you want it to do. You want it to produce a two-way graph. Specifically, you want a scatter plot. You want a scatter plot of wage and education. And there you go. You have your scatter plot. Now, let's say you want to add a line of best fit. It looks like there is a positive relationship between these. So we want a line of best fit, a line that minimizes the sum of squared residuals. So we're going to add to our existing command graph. And then to add to this graph, you do two vertical lines. And now what you want is not a scatter plot, but a line of best fit, which is LFIT, wage, education. Great. Now let's say you want to change the colors on this. There are different schemes in Stata, which you can find by going to Edit, Apply New Scheme. And so the current scheme is S2 color, but we may want something else. Let's say you want a monochrome graph. And that's going to look like this. Okay, we'll do one other scheme and then you can play around with this on your own. Let's say economist. Apply. And the graph will now look like something that you would find in the Economist magazine. Now, you can always copy this graph and paste it into your Word file. Okay, so now let's talk about how to find covariances. So the command for covariance is correlation, wage, education, comma, covar. So let's talk about what this is. So this is the covariance between wage and wage, which is the same thing as the variance. This is the covariance between education and education. Covariance of something with itself is the variance. Right, so the diagonals are just your variances, right? And your off diagonals, these are your covariance. So 4.15086, right? This is going to be the covariance between wage and education. Now, let's make sure that there are no missing values for wage. No, everybody has a wage value. Count if education. Everybody has an education value. Now, we can also calculate the covariance, quote unquote, by hand. So first what you need to do is to calculate the deviation of every value from its mean. And we need to do that for both the x variable and the y variable. So let's talk about how to calculate the mean and create a variable for that. Now that uses this command egen. Okay, so let's call this egen y bar or wage bar, right, to denote the mean wage. So that's going to be mean wage. Now let's generate the mean of education equals mean education. Now, for each, let's look at the data for a second, right? For each observation here, what we want to do is we want to calculate the deviation of wage from its mean and multiply that times the deviation of education from its mean. Right? So education, wage and education are the same for the entire sample. So let's go ahead and do that. Okay. And now this is going to be gen, okay, because we're generating a variable that doesn't really use anything fancy. So gen, let's call it covar1, since really the covariance is going to be the sum of all of these things. Okay. So covar1, right, equals wage minus wage bar times education minus education bar. And now what we want to do is, right, so what this has done is that for each individual in our data set, right, has created this value. And now what we want to do is to sum up over all of these values, right, so that we're getting the covariance for the entire data set. Okay, so we need egen, whoops, don't want to exit data. So egen, now let's call this covar, equals the sum of covar1 graphs. Now this should generate the same value for everybody, and indeed it does. Okay. Now you might be wondering, well, this looks different than the covariance you just showed me. And the reason why is that we need to divide by n-1, right? So this is the sum, but we have not divided, okay? So to create an average deviation of the means of these variables, right? So we're almost there. And what you can do is you can replace, we first need to figure out how many observations there are in the data set. So let's say sum wage. Okay, there are 526. So we need to divide by 525. We lose a degree of freedom here. So replace covar equals covar divided by 525. So now let's see, what are we getting for this value? 4.15086. Now let's go back up here, right? What was our value for the covariance? Ta-da! They're the same. Right? So now you can do the same exercise with variance, right, or any variable like this that you would like to calculate, say the sum of the residuals. So the last thing we're going to do is that, to generate the sum of the residuals, not the squared residuals, but just the residuals themselves. So in order to do that, we need to calculate both predicted values and residuals. So let's start by finding estimated coefficients for our variables. All right, so I want to create variables for beta 0 hat, which is our constant term. Okay. So beta 0 hat is here. All right, then I want to gen beta 1 hat, which is this variable here. And to make sure that I've gotten the values that my regression output table are, that my regression output table is getting me, I can do this. All right, and so you can see beta 0 hat, that value is the same. Beta 1 hat, that value is the same. All right, so everyone is assigned these values. So now let's create predicted values, right? So you could call this wage hat if you wanted to. And so the predicted value of y is just beta 0 hat plus beta 1 hat times the value of education. So let's look here. So now, right, we have predicted wages for everyone based on their level of education. Now we need to find the prediction error, the residual, so gen u hat equals wage minus y hat. Okay, now finally, egen, I need to create a name for this variable, u hat sum equals sum u hat. Okay, now let's see what u hat sum looks like. It's very, very close to 0, right? So technically the sum of the residual should be 0. In this case, because we're dealing with a sample, we get a little bit away from 0, but it's very, very close. So this video should help you do a lot of basics for simple linear regression.